So in previous lecture I cover the marks. Now the demarks concept in this lecture I will cover. So basically what is demarks? So demarks is just opposite of marks. So basically here is one okay, just a second. Okay, here is my input I. So basically one input and there are multiple outputs. So these outputs basically depends on my select line. So if my select line is n, so my output is 2 to the power n. So this input that is uh, selected by like this input going to any output of this, and which are actually selected by this n select line. So basically if we had a n select line, then we can uh, like maximum 2 to the power n output that possible. Take like we can take 2 to the power n output from demarks. And demarks, so 1 cross 2, 1 is to 2 demarks. So this is look like this. So where 1 is select line, 1 select line, 1 input and 2 output. And how to make demark circuit? So let's see. So this is my I. So if my I I is in both here, and this is my AND gate, and here is another AND gate. Okay, so I goes to here two AND gate, and how to choose select line. So here is I take the select line. So if it is bar like not, so not here, and S. So if my S is 0, then my this output we got, this is I0 and this output is I1. So if my S equal to 0, so my output, like I take Y0 and Y1. So this Y0 I will get, and if I choose uh, S equal to 1, so this output, this in output from AND gate we get like Y1. So this is my like gate level circuit. And for 1 cross 4 demarks, so how we can make? So for 1 cross 1 is to 4 demarks, obviously there are two select line is possible, like we need two select line. So that is uh, for if we want to get output from Y not, so then this is my uh, like S1 bar, S0 bar, and I we add them and we got the output. So here is Y1, Y2, and Y3. So that's the way we get the output. Now here 1 is to 8 demarks. So 3 select line S0 to S3, and here is my input, and here is my total 7 output. Sorry, 8 output, which is actually Y0 to Y7. So demarks with enable signal. So enable. So here is one extra signal, that is enable. So where my enable is on, that time only it gives me output. Otherwise, if enable is off, so that times it not gives me the output. Basically, in this case, this is the example of active high enable, and this is the example of active low enable. So basically, when my enable signal is 0, that time it gives me the output, and where is my enable signal is high, that time it does not provide me any output. And here is the input, and here is the two select line for Y0 to Y3, like my output. Find the all output. Okay, so find all output, here is not get. So obviously this is bar, so like this, like this, like this. Okay, just like if you are here what do we get? Like select line is a bar, and b bar. So basically a bar, b bar, and I you and get, and then not. So it's basically a bar, b bar plus I bar whole bar. So basically a plus b plus I bar. So basically like this. This is the my circuit. So this is for basically just a second. Wait for saving the PDF. So here is my M naught. This is my M naught. Like it is like in max term. So this is my M naught plus I bar, and this is my M1. Not M1. I think M1 plus I bar. Okay. So here it is like M1 plus I bar basically. Here it is M2 plus I bar, and here it is M3 plus I bar. So it's basically the maximum, like max term. Active low Dmax. So here it is my active low Dmax. That is how this circuit will operate. Basically, why not? Okay, active low, for active low Dmax. This is my not gate output, and this is my, so this is my active low, like S plus I bar, S bar plus I. So this is my active low type of demarks. Basically, just in previously active high means just take one input to, if suppose one select line, so two output. So this is my not get type of thing. So if you put not get here, then it becomes active low demarks like this. Here is active low demarks of 1 is to 4, 1 is to 4 demarks. Find the min terms of ya and max term of yb. Find okay. Here is max term and here is my min term. Okay, how I can get? Okay, for here my input is like y naught and y1. So y1 is a bar, b bar, and here is 1. So 1 and y1. Y1 is my a bar, b, and 1. And how I get the how to how I get the output of this gate. So basically your a bar b and whole bar. So basically this is my a bar b whole bar, and it is XOR gate, XOR with this is my OR. So basically what is the output of OR gate? Basically this is my a bar b bar plus a bar b. So if I take common of a bar, so basically it's a bar. My output is a bar, and then if I do XOR, then how I can do? So basically XOR. So a bar b. Suppose I take this. So a bar b XOR a. So this is my so what is my output XOR? So a bar b into a bar plus a bar b whole bar into a. So if it is a bar, then obviously it would be like a plus b bar into a. So it would be like this. So basically a bar b plus a plus, so a b bar plus a b plus a b bar. So a b bar is already there. So it's like a plus b. So it behaves like OR gate, or it is like min term. So what is the output like for min term of y of a? So for y of a, min term would be 1, 2, 3. Okay, and here for here, what is the max term? Okay, for max term, how I can write? Okay, just a second. Remove this part, and here we can write. So for max term like y2, so a b bar and a b. So this is basically 0. So if it is 0, then how the max term? For max term, like suppose everything is 0. Just a second. So this is my like min term. So everything is 0. So for what is the max term? For max term, like everything is present. So that's why 0, 1, 2, 3 is my like max term. So that's the output like max term of YB. And method 2, what is the method 2? Okay, just M2, M3. So like this way you can also represent. Not a big deal. Find output YA and YB. So obviously you know the demarks and just go through the step by step process. You will get the output. So implementing higher level demarks from lower level demarks. So how we can? So already we see that how to make marks. Suppose we have to make a 8 cross 1 marks by 4 2 is to 1 marks. So in previous video we already explained. So the same way we can also make demarks. Like suppose 1 cross 16 demarks by using 1 cross 2 demarks. So that also be possible. So I go through a small example like 1 is to 4 demarks by 1 is to 2 demarks. Okay, so how I can make? So basically this is my 1 is to 2 demarks. So there is one select line 1 is to 2 demarks. So here this select line. Okay, just a second. So here is another demarc. So that input is here goes to, and this input is goes to this demarcs, and here it's my two output. Suppose this output name is y0, y1, y2, y3, and this is my select line. So if I want to select this, then my S1 is here and S0 is here, S0 is here. So my S1 is 0. So obviously this is my 0, this is my 1, this is my 0, this is 1, this is 0, this is 1, and this is my input I. So if my S1 is 0, then okay, just change the color. If my S1 is 0, then I select this. Okay. If this is selected, then this the input of this marks. Where S1 is S0 is select line. If my S0 is again 0, then this 0 is the output of this y not. Okay, so that's the we get y not. If my s not is suppose 1, and then we get y not. So 0 1 is y1, and if suppose my s1 is 1, then we choose this marks, and we taking the output by from s not, like select the input of s not. S not is 0 or 1 maybe. So this is y2 and y3 as we get. So if suppose we want to make a like 1024 is to like 1 is to 1024 demarks by 1 is to 2. So there how many demarks will be required to 1 is to 2? So that is, what is this scale? I think how to remove this scale. Okay. Oh, great feature. Okay, whatever. I forget. So how to so one is to 1024 demarks we can make by 1 is to 2. So basically we need 1023 demarks. So basically how we can do 1024 by 2, that is 5 uh 500 512. If you buy 2 again, so 256. So that's the way. If you add 512 plus 256, something like dot that to 1, so you find 1023. Okay, I hope this concept will clear now. This sounds so it's no. So that is my 1 is to 2 dmax and 1 is to 8. So obviously 7 dmax will required. So this the way, just divide like 16, 1 is to 16, so 16 is the upper, 4 is the lower. So 16 by 4, that is 4, 4 by 4, that is 1. So obviously here 4, this 4 we take 4, and 4 by 4, that is 1. So total 5 dmax. 5 uh, 1 is to 4 dmax will required. And here is the like questions. Implementing the following function using dmax. 1 is to 0. So basically this function we want to implement, so how we can implement. Okay, so this is my select line ABC, and it is my 1 is to 8 dmax, 1 is to 8 dmax. So this is my input 1, and we need this min term. So how we can get this min term? So basically this is 1, so we take output from M1, and 4, so this is my 4, and 4 6, so this is my 6, and 7, this is my 7. And now this, if we are doing OR, so obviously the output we get. And active high, for active high, this is active low, this also active high, but what is the difference between this and this? Hmm. Okay, so another way we can do that is by using NOR gate. Okay, so we take the this input. So basically whatever the in the question like 1467 they required, so basically don't we just take the other inputs, m0, m2, m3, m5, and we just NOR them, and we got the this output, the previous as same. Here is the active low, how to make active low. So basically just take this, and so basically what is the bubbled AND gate that represent also NOR gate. So just like bubbled, here bubbled, and so this is like NOR gate. And active low, so basically this is active low, and this is also active low. And how we can make, so whatever the input they told, so we take the input from this, and we just take we just give the all output into the like input of this NAND gate. Basically, so basically this is my bubbled, and if I just remove this part, this is my bubbled and means like NOR gate, and here is one NOT gate. So basically this will cancel each other. So basically everything represent is like a OR gate. So this is my output. So now next topic is decoder. So basically what is decoder? It's like converts binary information to a symbols or number. So basically converts binary information to symbol or numbers. So that is like decoder. At a time, only one output line is active based on the input. Okay, so at a time, only one input line is active based on the input combination. And here is my n cross 2 to the power n decoder. Basically, it represents, suppose It represent like we had n line basically from 0 to n. So 0 to n minus 1. So total n line is present. So maximum you represent 2 to the power n output. So that's only you represent maximum 2 to the power n output. So in previous in decoder and what's the difference with decoder and demux? Basically in decoder we don't have a select line, but in demux we have a separate select line. So their input line is different and select line is different, but here you can say what is your input, that is also like behave as a select line, you can say that. So basically if suppose if you put like 3 cross 8 decoder, so if your input is like suppose 1 1 1, so it select the your outputs number 7 basically. And if it is 0, everything is 0 0 0 0, so it select your output 0. So that's the way it's work basically. So here example of 1 cross 1 is to 2 decoder, and here x is my input and also select line. If suppose 0, then this 0 is the output of y0, and if it is 1, then this one goes to here, so it is y1. So this is my like uh, you can say that it is like converts binary information to a symbol or number like that. And here is 1 cross 4 decoder, sorry, 2 cross 4 decoder, it would be it 2 is to 4 decoder. So active high enable, so enable pin is here and active high output. So here we take the extra line that is enable. So if my active high is like high, so that time only it gives me the output like M0, M1, M2, M3 like this. And if my input is 0 0 0 0 0, then my output is Y0 1 1. So suppose X1 is 0 0. Okay, so my Y0 is 1 and rest of the bit are 0. So 0 1, then 1. If 1 0, then 1 1 1, then 1. So full truth table here, enable signal also there. So here is 1 1. Everything is 0. When enable is 0, so everything is 0. When enable is 1, so here is y not 1 1. That now select 0 1 1 1 0 1 1 1 1. How to design the circuit? Suppose we have a two input and my enable is also present. So how we can design the circuit? Let's see. Okay. So I want output from like y not is here. So if my here is my AND gate. So basically here is my another AND gate. Here is my another AND gate. Here is my another. So now if I take three input, so three input. So now if I connect, so this is my basically I naught, and everything is connected with I naught. This is my I naught. If suppose this is my, so this is my I1, and here it is my connected. Here it is. And now if I take enable signal, so here is my enable signal. So this is the basic circuit of the decoder. Basically just it's covers with AND gate. And here is my output y0, y1, y2 and y3. So this is my the circuit, like circuit representation of two is to 4 decoder basically. So you can see here. But okay, one thing I did mistake, I think. Okay, for here my okay. So here both input is like my here not gate, here not gate. Then it going to give me the output. If my input, so I naught is my LSB, I1 is my MSB. So here this is my not gate, and here this is my not gate, and here nothing is not gate. So we can also minimize. Suppose we need to, so extra two not gate is required, but here I represent it 4 basically. So this is my I naught. So basically y0 is equal to I naught bar, I1 bar, and enable signal. So this is my y naught, y1 for y1. Basically I naught is LSB. So basically I1, and here is my I1 bar and enable this like for y2. I naught is here, I naught bar and enable. Here I1, I naught and enable. So active high enable and active low enable, low output. So here you can see what is sorry. So this is my x0 and this is my x1. So x1 is MSB and x0 is LSB. So active low. This is my active high enable. So active high. Okay. Active high enable. Okay, and active low output. Active low. Then here is not get not. So whatever the output we want to select by this input, like suppose my x0 is 0 0, except y0 everything is 1, except y0 everything is 1, you can see here. So whatever the output we want to select, so except that everything is selected, like everything is 1. This is my active low output. And active low enable but active high output. So active high output means there is no like not gate. Okay, no not gate, but not gate is here active enable. So when my enable signal is 0, enable signal is 0, that time this circuit will work, but when enable is 1, that time this circuit will not work. Active low enable and active low output. So active low, so here is not gate, here is not gate, not gate, not gate. So this is my active low output and also active low enable. And this is my 3 cross 8 decoder. Basically this is my 3 cross 8 decoder. By 8 output we can select from 3 input. If no enable given, consider the device in working condition x0, x1, x2. So x0, x1, x2, y0, y1, y2, y3, y4, y5, y6, y7. So okay, this is my basically active low output type of no enable signal given, consider the device in working condition. So basically this is my active low output type of 3 is to 8 decoder. Decoder versus demux. So basically this the difference. This is my demux where the select line is present, but here is no select line. Okay, so basically here is the enable signal in decoder we give, and y2 y not equal to m1 m not into enable signal. Here is also m not into I1. I'm not so almost same everything, but the almost same, but the difference is that this select line is here and here is no such a select line. Generate all possible mean terms of any two variable function. All mean terms should be separated. Generated m0, m1, m2, m3. So that's the way you can generate by decoder and demux. Write down the output. So LSB is C, MSB is D. So here is my YA. Okay, 2 is to 4 decoder. And here is my enable signal. So obviously C bar D bar, C D bar, C bar D, C D, and it's multiply with my enable signal. Implement the following logic function using 3 is to 8 decoder. Make all possible design. Okay, so from decoder, okay. So ABC. So this is my LSB. So we first like only go through the active high output. So just take the output and doing OR. So this is, and if we do like active low, then how we can do? So for active low, so this is suppose active low, 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 so everything. So we take the output from here, like not like which the output in active high output situation we don't take. So we take that output. So that is like bubbled. If we took the bubbled or nor, you can say bubbled and or nor. So if the suppose my output is like a plus b whole bar, and this is already sorry, this is my nor. So what is the opposite sum like? Suppose okay. So suppose my 4 here also we can represent directly go through. So if my active low output, so m not m2, sorry m3, that is m3, m5, m6, m5 and m6. So if we do bar, then we get the m1, m2, m1 plus m2 plus m4 plus m7. Okay, so by active low with bubbled AND gate or NOR gate, if we it is like active low output, then we solve by uh, AND gate or non NAND gate we also can solve. So here if it is active high, then we go through the NOR gate, and another way if it is active low, then we just take the output from opposite which are actually not in the mean term, so that's we take and we just end it, we get. And another way we take the same input with active low output, but we use as one NAND gate. We used one NAND gate. That's all. So write down the mean term of y. So here we can analyze the circuit and we can write down the min term. So tri-state buffer. So what is tri-state buffer? So basically in buffer what happened, like whatever the input we give, so after some delay we got the output. But in case of tri-state buffer, what happened? Like you have a enable signal. So when you put the enable signal high, so that time the circuit will work and it works like a buffer. Like after some delay, it's give you the output. But if suppose the enable signal is not on, so that time what happened? The circuit give you a circuit like don't provide the output. Even the input is present. So after suppose the circuit like the buffer is like TD, like after 10 nanosecond delay you get the output. But if enable signal is low for active high buffer, then you don't get the output. And also like enable signal like active low buffer also be present. So for active low, so if you don't give the enable signal 0, then you don't get the output. And also like tri-state inverter is possible. So for inverter case, like whatever the input you gives, like in inverter, like in inverter, what happened? Try like inverter. If you put the input, so put the input like suppose my input is one, and what is the output? Output should be like after 10-second delay. So for ideal case, it will be like not any delay, but in real, like in real life, so you get some delay. So after like suppose 10 nanosecond delay, you get the complementary output of the input. So for enable, when the enable signal is high, so that time you get the output, otherwise not. Okay, output can be like output would be the output. It's just opposite the input. So tri-state inverter. So basically, where the your enable signal is high, so that time only gives you the complementary. Uh, your output should be the complementary input. Okay, and if enable signal is low for uh, like active high, then it does not provide any output, and for or it's behave as a high impedance. And if my enable signal like for active low tri-state, so that times like only when enable signal is zero, that times like your y is basically the x bar. So implementing marks from decoder, 2 is to 1 marks from 1 is to 2 decoder. So how to implement? Okay, let's see. Your 2 is to 1 marks from 1 is to 2 decoder. So how marks look like? So this is my marks. So 2 is to 1. So here is one select line and 2 input. That is my basically I naught I1, and here is my output Y. Okay. So you want to make a marks by 2 is to 1 marks from 1 is to 2 decoder. And for decoder, how it looks like? So your decoder looks like 1 is to 2. So here your decoder. Okay. So how you get the output? So 1 is to 2 decoder. So here is my I and here is my Y naught Y1. Basically, you can say another way, you can write, but select line so that uh, here is my input, here is my output, here is my output of decoder. So it should be behave like this. So how I can make? Okay. Okay. Basically, so here is my one buffer, tri-state buffer. I put here is my tri-state buffer. Okay, just a second. Here is my tri-state buffer, one another. So here is my decoder. Basically, decoder. Uh, Here is select line one. So I put like select line, and here is for my this buffer. So B naught and this B1. So this B1 goes to this input of this, and this B0 goes to this. So it is tri-state buffer basically, and here is your output, that is basically your input I0, I1, and here you just OR, and this is your Y. So basically that's the way I think you can make. Let's see the answer. It is correct or not? So okay. Okay, so your select line is this. So this is your okay, the same. This is your select line. So 1 is your 2 decoder. Now you give the like select output like y1 to this buffer and this buffer, and here is your I0 and I1, and this goes to the output. You can like weird directly, or it's like behave as a weird or type of things, or like you put a or get also, that like it's a common solution. 4 is to 1 marks around 2 is to 4 decoder, so you can make like this, and vice versa is possible or not. Let's see, higher order decoder from lower order decoder. Okay, so you can make like this way, higher order decoder. You need to make higher order decoder by lower order decoder, and one is to two, 3 is to decoder. So you can make like this way. 5 cross 32 decoder using 4 cross 16 and 1 cross 2 decoder. Okay, so that's the way you can do decoder. So suppose my decoder, like we want to make a 4 is to 16 decoder. Okay, by 2 is to 4 decoder. So how to make? So here is your 2 is to 4 decoder. So here is your output. Here is your 2 input. Again, that. Yeah. And here is your select line, like enable line, you can say that. Now here is your another 4 output, 2 is to 4 decoder, and here you connect like enable goes to here, this enable goes to here, this enable goes to here, this enable goes to here, and this is your output. Why not to Y15? And if suppose my MSB A B C D, okay, so AB is your MSB, so here is the MSB, so AB, so this is my A bar B bar, this is A bar B, this is AB bar, and this is my AB. Okay, so here is my CD. Everything is CD, CD, and CD. So that's the way you can make like decoder. Like small by using like big decoder, you can make by small decoder. And also like the 256, you can do 8 into 256 decoder. We want to make by 16, then 256 by 16. That is 16. 16 by 16. That is 1. So 16 plus 1. That is total 17 decoder required. here. So now it's the encoder. So in next lecture, I will upload the encoder video basically. So basically, it's nothing but opposite of decoder and to the power n inputs and output. So in next video, I'll upload. Now stop the lecture and bye, guys.